So let us discuss bubble sort, which is one of the simplest sorting algorithms. So general aim of sorting algorithm is to sort an unsorted array and put it in ascending order or descending order. So now, as an example, consider an unsorted array with 5 elements: 10, 5, 2, 32, and 7. So here we are taking as an array, the index positions are 0, 1, 2, 3, 4. So now in the first pass of the algorithm, we compare every pair of elements and we move the largest element to the end of the array. So what we do is we first compare 10 and 5, and 10 is greater number, so we swap it. So look at the second step. 10 and 5, 10 is greater, so 10 is swap. And again we compare 10 and 2. We see that 10 is again greater compared with 2. Then we swap 10 and 2. So we get the result 5, 2, 10, 32, 7. Again 10 and 32 is compared, but 10 is smaller compared to 32. So no swapping is done. So when the number is smaller, we do not swap it. So now consider the next pair, 32 and 7. 32 is greater, so we swap it. And finally, we get the result as 5, 2, 10, 7, 32. And we can see that 32 is the largest element in the array, and that is moved to the last position. So therefore, the last position is fixed. So now we proceed to step 2, which is pass 2. We repeat the same step for the first 4 elements, leaving the last element. So taking the first 4 elements, again comparing 5 and 2, 5 is greater, so swap it. Again comparing 5 and 10, 5 is smaller, so no swapping is done. Again comparing 10 and 7, 10 is greater, so swap it. So we move the next largest element 10 to the next position. So the last two positions 10 and 32 are fixed now. So the remaining elements are 2, 5, 7. So in pass 3, we repeat the same process for these three elements 2, 5, 7, and we find that 7 is the greater element. So the next greatest position is fixed as 7, 10, 32, and we have to continue our pass number 4 with elements 2 and 5. Out of 2 and 5, we see that 5 is the greater element, so that position is also fixed in pass 4. So now we left with only one element, so no need to continue further. We stop the process. So the final result is 2, 5, 7, 10, 32. So now let us try to write the algorithm now. So in our example, we have considered 5 elements. So we need 4 passes. Suppose we take n elements, then we need n minus 1 passes. So for that, we write a for loop, outer for loop, which stands for the number of passes. For I equal to 0, I less than n minus 1, I plus plus. So for loop here runs for I equal to 0, 1, 2, and 3. That is 4 passes. And when the input is 5, we put the condition as I less than n minus 1. Suppose we take I equal to 0. When I equal to 0, then in the next step, we have to compare the elements and move the greater. So how we are doing the comparison? We compare when I equal to 0, we compare 0 and 1, 1 and 2, 2 and 3, 3 and 4. So we can see that we are running the next loop with the index values 0, 1, 2, 3. And we have to compare a of j greater than a of j plus 1, and the for loop, the next inner for loop runs for j equal to 0, 1, 2, 3. When I equal to 1, we have to compare 0 and 1, 1 and 2, 2 and 3. Again, when I equal to 1, j should run with 0, 1, 2. And similarly, when I equal to 2, we have the comparison 0 and 1, 1 and 2. J should run with 0 and 1. So again, when I equal to 3, we have to compare 0 and 1, and J should run with 0. So just for better understanding, we will tabulate the result. I and j. When I equal to 0, j should run for 0, 1, 2, 3. When I equal to 1, j should run for 0, 1, 2. When I equal to 2, j should take the value 0 and 1. When I equal to 3, j should take the value 0. So how to generalize this? So that generalization can be done by taking n minus I minus 1. So n stands for the number of input 5. So when I equal to 0, 5 minus 0 minus 1, you will get 4 times for the first case. And when I equal to 1, you will get 5 minus 1 minus 1 3 times, which is nothing but j equal to 0, 1, 2. When I equal to 2, we get 5 minus 2 minus 1 equal to 2, which is nothing but j equal to 0 and 1. When I equal to 3, n minus I minus 1 will give you 1, which is nothing but j equal to 0. So generally, we can write n minus I minus 1. So the inner for loop is written as j equal to 0, j less than n minus I minus 1, j plus plus. The comparison statement, if a of j greater than a of j plus 1, if this is true, then we have to swap the values. For swapping, we use a temporary variable and swap it. So the complete bubble sort function is written as bubble sort with parameters array and the number of element. And for I equal to 0, outer for loop is number of passes, which is 1 less than the original input. So I less than n minus 1. And the inner for loop is j equal to 0, j less than n minus I minus 1. And we compare, and then if it is true, we swap the values. This is how the bubble sort will work.